Hey folks, this is Captain Jones here to talk to you really quick about two methods of loop control. This is going to help us understand the character count program next. There are more or less two ways to control a loop. The first way is with a counter. The kind of defining feature of this type of loop control is that we know ahead of time effectively exactly how many times our loop's going to execute. And the other method of loop control, which we'll get to in just a minute, is called loop control with a sentinel. And what that means is effectively we don't know ahead of time how many times our loop's going to run. It will terminate when a specific value is reached, and that specific value is called the sentinel because it indicates that the loop is terminated. But that could be after one iteration, it could be after 1,000 iterations. And so that's kind of the defining feature of these two loops. You might imagine the loop control with a counter is kind of similar to a for loop in many programming languages because by definition those loops have to know or in most cases have to know at the start exactly how many times they're going to iterate, whereas the loop control with a sentinel is kind of similar to a while loop in many programming languages, which means that this loop is going to continue any number of times, and it only kind of terminates when the while condition is suddenly false. So in the LC3, here's kind of how we do this for the loop control with a counter. You can see a sample flow chart here for a program that is going to add up the numbers in memory locations 3100 to 310B. Specifically those memory locations. So we know right off at the start of the program that this loop should run a total of 12 times. And so what we're going to do is load R0 with that value, and then each time through the loop, decrement that counter by 1 and exit our loop when it reaches 0. So for a loop with a counter, it's very common to start with a positive number and decrement on each cycle until we get to 0 and then kind of exit the loop. I suppose potentially you could start with a negative number and increment up to 0 if you wanted. In either way, or in either case, it's easiest to sort of count your way towards 0 because remember that this diamond here is going to get converted into a branch instruction, and the LC3, like many computers, does not have like a branch if the condition codes are equal to some value or something like that. We have branch if negative, branch if positive, branch if 0. And so this condition is quite easy to check as long as the terminating condition is if the register equals 0. So you can see that kind of implemented down here. This unconditional branch, or I should say 3008, this is where we sort of decrement the counter R2. We make that unconditional branch back to 3004, and here's where we branch based on the value in R2 branch of 0 to something, some value underneath our program. And so it's important to just make sure when we're writing this out that if we're testing R2 in this box here, then that R2 was essentially the last program or line of code that was run that could have set the condition codes before it's checked. So by which I mean, we're setting the condition codes right here. If there were another instruction in between decrementing R2 and branching that were to update the condition codes, then this branch here would not be testing R2. So then the loop control with a sentinel means, again, that we're not sure how many times our loop's going to run initially. So we have to test against some condition. So this slightly different example, we are still going to add up some numbers that still start at 3100. But in this scenario, we don't know ahead of time how many numbers we want to add up. But we're going to set up the problem so that we know we've reached sort of the end of the list when we get to a negative number. And so R4 is it equal to the sentinel? In this case, is equivalent to, is the next value in our list, is it negative? So in that case, the way this code's set up is that each time through the loop, we perform our addition. R3 gets R3 plus R4. We increment R1, that's the address of the next value we're looking at. R4 gets the next value in the sequence. And when we come back to our loop, we're going to say, is it equal to the sentinel value? In this case, it means, is R4 negative? In this code example, we have a fairly easy way to do that, right? So we can branch based on a negative value. So even though we don't know how many times this loop's going to run ahead of time, um, we have a relatively simple branch instruction that after sort of we load R4 and branch back to the top, we just have to test if that value is negative to know if we go back into our loop or jump, to the code that's below our program. Um, Another really common flavor of this kind of loop control with the Sentinel is to test if, like in this scenario, if it wasn't just sort of, carte blanche, if it was like negative numbers that were, to sort of terminate the loop, but if a specific value, like if -1, it marks the end of the loop, or the number 0 marks the end of the loop. So in which case, we can't necessarily just kind of branch based on if a value is negative. What we'll need to do is, if we're testing for a specific value, effectively the easiest way to do that, and we'll see an example of this later on in the character count program, the easiest way to do that is to subtract the value we're testing from the specific value we're looking for, which is stored in memory, or the other way around. But if they're equivalent, then the result of that subtraction will be exactly 0. And so in that case, we can perform the subtraction and then branch on 0, and otherwise continue our loop or exit based on that. Okay, so you'll see an example of one of these in the character count program. But otherwise, folks, that's all I got. That's loop control with 2 methods via counter and a sentinel. I'll see you next time.